In the last section, we put together a big mega example with a couple different pieces of code from several different files we've worked on before. When we ran this file, we saw some really interesting behavior. So I'm going to run it one more time over here. So in the result, we see the HTTP request come back first. We then see exactly one hash, then the file system callback, and then the remaining 3 hashes as well. So there's a couple elements here that seem to be very, very interesting to me. First off, why do we always see exactly one hash console log before the result of the file system? And then secondly, why do we always see the HTTP request complete first? Both the HTTP request right here and the file system are both asynchronous calls. It takes some amount of time for them to complete. So why do we see always the HTTP one finish almost right away, or relatively right away, but then the FS module call right here always seems to be finished after the first hash? Well, in this section, we're going to take a look at a couple different diagrams and try to figure out exactly why this is occurring based on the knowledge we've now picked up on the event loop. So let's get to it. Now, this is the real crux of the issue right here. This is like the entire grounding to understand why we're seeing this behavior. Remember, in the last couple of videos when we were talking about the event loop, we had said that internally, Node makes use of a thread pool for some very specific function calls. In particular, almost everything inside of the FS module or the file system module makes use of this thread pool. And as you and I very well know, that crypto module function, pbkdf2, also makes use of the thread pool as well. However, the HTTPS module that we're using does not make use of that thread pool. And instead, it reaches out directly to the operating system and leverages the operating system to do all that networking work for us. So while the FS module makes use of the thread pool, the HTTPS module does not. So with that in mind, let's now take a look at the kind of timeline of what we just saw. So I think this right here, we'll just look at this diagram for a second. This is just kind of clarifying the time that we saw on all the console logs. So the HTTP call resolved right away, but we had to wait a really long time for all the other function calls for some reason. Let's take a look at what this read file function call right here is doing, and then maybe some of the pieces are going to come together and you're going to start to understand why we are always waiting for the read file call to take so long to complete. Okay, so this is more or less what that read file call is doing internally. You don't have to really understand exactly every step that's going on here. There's just one thing that I want to point out distinctly about what happens when we call read file. So when we first call read file, Node does not just go directly to the hard drive and immediately start reading the file. Instead, it looks at the file on the hard drive and it tries to gather some statistics about it, like how large the file is. That entire process includes one round trip to the hard drive. So we go to the hard drive, we get some statistics about the file, and then the result comes back to our program. After Node has those statistics, it now knows how large it can expect that file to be, and then it is now ready to actually go and read the file. So then Node actually goes back to the hard drive, gets the file contents, and returns them to our application. And then eventually calls our callback, and that's when we saw our console log. So the really key thing to keep in mind here is that there were 2 distinct pauses that occurred. We had one pause in this entire read file call where we were just waiting on the hard drive to return some statistics about this file. And then we had a second big pause as Node went back to the hard drive and started to actually read the contents out. So with this in mind, let's now look at the final diagram that really explains what was going on. Okay, so you can see we've got a couple different elements here in this diagram. On the bottom, we've got that same thread pool that we were talking about previously with its 4 default threads. Now the first thing to realize here, so this is why this is such a good interview question, is because it really makes you understand a lot of different pieces of Node. The first thing to realize is that the HTTPS module call, it's really HTTPS, that does not involve the thread pool at all. It completely skips the thread pool and makes use of the underlying operating system. So when we make that request, it doesn't care about what else is going on inside of our program. It doesn't matter. It makes the request, and as soon as we get a response back, the response is returned to our code inside the event loop, and then we see that console log appear immediately. So the HTTP request, I just kind of threw in there so that you have the reminder of, oh yeah, this happens outside the thread pool. Now the reason that the fs module call got delayed so long is specifically because of the way that the thread pool works. So the instant that we made all those function calls, like these calls right here, you can kind of imagine that it set up 5 different tasks to be executed inside of our thread pool. First, it said, okay, we need to go read the file. And then it also said, okay, also in this thread pool, we need to do 4 hashes. So once those 5 tasks all got loaded up, the first 4 each got assigned to some thread. So the file system call got assigned to thread 1, then pbk df2, the first call, went to thread 2, 2 went to 3, and 3 went to 4, and so on. Now threads 2, 3, and 4 right here are going to immediately start churning away at these hash calls, and it's going to try to calculate those hashes as fast as they possibly can. And meanwhile, thread 1 over here is going to start working on the file system call. Now here's the really critical point. The instant that the fs module call got loaded into thread 1 started to go through this process right here. So it said, okay, let's see, I have to do everything revolved around reading some file, whatever. Well, I guess I'm going to go get some stats about that file. And then it went to go get some hard drive, or access the hard drive and get some information about that file. Now during that phase, thread 1 starts to reach out to the hard drive. And as soon as thread 1 puts that request into the hard drive, this thread right here then realizes, hey, you know what? I'm going to be waiting for quite a while. I'm going to be waiting like forever on this hard drive to get me some information back. So I think that while I'm waiting for that information, I don't care about this fs task anymore. You know what? That fs task, it can just sit around and it can wait, because I have to wait literally forever to get some information back from the hard drive. So as soon as it reaches out to the hard drive, thread number 1 then says, hey everybody, I'm available to do something else. Oh, I need to calculate some hash for pbk df2 call number 4 over here. Great, I'm going to start working on that. And so thread number 1 temporarily forgets about that file system call, and it starts calculating hash number 4 over here. Then eventually, out of thread 2, 3, and 4, one of these is going to finish. So one of these is going to finish. Maybe it's the thread 2 working on call 1 right here. So this call gets completed, and now thread 2 has now been opened up. Thread 2 finishes that first hashing function. It does the console log, which is what we saw right here. And then thread 2 says, okay, I'm now ready to pick some work back up. So thread number 2 sees that there's still the pending file system call that needs to be worked on right here. Thread number 2 then looks to see if it has gotten any information back from the hard drive, like those statistics that we were just talking about. And in this case, yes, it has. So then those statistics, I know this diagram's starting to get crazy, but you can imagine that these statistics come back into thread 2, and then thread 2 starts continuing work on the file system call. It then makes another follow-up request to the hard drive to get the actual file contents, but this time when it makes that follow-up request to actually get the file contents, like this step right here, there's no other work for it to do, so it just sits around and waits for it to come back. And then as soon as those file contents come back, then thread number 2 processes them, and we then see that console log appear. So that's why we saw over here, we always saw one hash get completed before the file system module. Because we queue up that file system call, that thread does some initial work, it makes a request over the hard drive. That thread then says, hey, you know what? The hard drive's going to take forever. I'm going to do something else. And so it picks up one of the other hash calls. It starts working on that, and then eventually another thread will finish some hashing call, and it will go back and continue working on the file system. Whew. All right, so that's it. That's what's going on behind the scenes here. Like I said, I think this would be like the most insane interview question ever, because it really requires you to understand exactly what Node is doing internally. You have to understand, first off, that the HTTP module does not work with the thread pool. You have to understand that the FS module does, along with the crypto module pbkdf2 function. And then you have to also understand that the thread pool by default has 4 threads available to it. Now, just one quick thing I want to throw in here as kind of a follow-up tricky question, maybe not that tricky, if we went and increased the thread pool size inside of multitask.js, remember we can do that at the very top by setting this environment variable. So if we increased our thread pool size up to 5 and then ran this file again, what do you think would happen? Well, I bet you could take a pretty good guess here. So when I run this, now we have an extra thread that can be 100% responsible for everything that the file system call needs. And so that 5th thread is now entirely dedicated to working with the hard drive and doing whatever needs to occur. And that's why now we see the result right here appear immediately. And then likewise, if we go all the way down to 1, so only 1 thread now, this 1 thread is going to do some initial work on the file system call. It's then going to say, okay, file system, we're waiting on the hard drive, I'll catch you later. It will then process all 4 hashes, and then eventually once those are all done, it will then resolve or do the rest of the work for the file system call. So if we now do this, we'll see hash 1, 2, 3, 4, and then the result of the file system call. And all the while, the actual HTTP request is completely unchanged because it's not touching the thread pool at all. All right, like I said, I was super excited about this because we finally got through all the event loop stuff, and now you can start to really understand this crazy behavior that you start to see in Node. So this has been a lot of fun. Let's continue in the next section, and we're going to start looking at some performance of Node. So quick break, and I'll see you in just a minute.